people are still getting in, if you don't mind?
Of course.
Yeah, they are just still getting in. 1 minute.
Oh, I can see the participant numbers growing. Okay.
Yes.
Happy to wait. All right. Well, why don't we
please go ahead.
get started. Good evening, everyone, and welcome to our June version of the USAID-funded Center of Excellence for Water webinar series. And we have a very interesting topic in which we learn a new and important way to deal with greenhouse gases, and that involves greenhouses, because as I think all of us know, the challenge of climate change is not just in cities, not just in major farming areas, but actually all over, including rural areas where we have villages, farms, all faced with the challenge of the changing climate. And today we're going to be discussing some greenhouse management and practices that would help rural farmers with their ability to deal with climate change. We have, I should mention that I'm Brent Haddad. I'm a professor of environmental studies at University of California, Santa Cruz. We have two excellent speakers to share their research with us. Our first will be Professor Mohammed Abdurrahbo. He's a professor at the Egyptian Agricultural Research Center. Professor Abdurrahbo is interested in greenhouse management for vegetables and fruits. He was the head of the Agrometeorology Research Department for several years. He has served as the Egyptian National Consultant for the Food and Agricultural Organization. He has taught about climate change and irrigation management, and he has served as the focal point for the Ministry of Agriculture in the Climate Change Risk Management Program. And so he'll be talking about his important research on this topic. Our second speaker will be Professor Abdul Azim Negm, and he is a professor of hydraulics and water resources at Zagazig University. Professor Negm is a member of the International Association for Hydro Environment Engineering and Research, and the head of the Egyptian Permanent Scientific Committee for Water Resources. He has a remarkable publishing record of more than 350 papers, 100 book chapters, and 34 volumes. And in fact, the Center of Excellence has really benefited from his published materials in its own research and efforts. Professor Negm has served as the Secretary General of the International Water Technology Conference and as editor-in-chief of the Egyptian International Journal of Engineering Sciences and Technology. And with that, why don't we start with our first speaker, Dr. Mohammed Abdurrahbo.
Okay. Hello everybody, I am going to talk about the greenhouse management and practices in Egypt for different crops in Egypt. I am a deputy of Central Laboratory for Agricultural Climate and a member of the project ID 30771 funded by SDF. This is the training materials for that. The main topics I will talk about is common greenhouses structure in Egypt, understand the importance of the greenhouse sector in Egypt, climatic conditions under the greenhouses, tropical fruits under greenhouses, especially mango for improved under the net houses, soil sculpture techniques and practices in Egypt, irrigation requirements under greenhouses in Egypt based on the climatic data. Why Egyptian government increase the greenhouse sector? They try to increase the production per water unit because the water shortage in Egypt, we know about that. We have water scarcity in Egypt. To save 30 to 40% of the water for the same quantity of vegetables and improve the quality of the vegetables, higher quality quantity and better quality, and also food safety issues. And going to intensive production per land unit because the arable land in Egypt is very rare, and then we move to the desert to establish these greenhouses and leave the arable lands in Nile Valley and Nile Delta for the cereal crops, and increase the area even in poor soil, that's using soil sculpture techniques in the new soils, encourage the production for and export fresh vegetables and cut flowers to foreign countries to make the whole farm for the Egyptian farmers. Availability of the fresh fruit and cut flowers all over the year for the Egyptian people, encourage the availability of high technology in the agriculture sector because the greenhouse always is forcing for the new technology inside the agriculture sector. Enhances the national income, reducing the unemployment rates, providing job opportunities about 600,000 persons. Establish the agricultural community in the desert area for 1.5 million acre mega project. National mega project in Egypt, 100,000 acre of greenhouses in Egypt. The project in the 7 main areas, the implementation of the greenhouse in these areas is distributed all over the western desert from the coastal area till the upper Egypt areas. Most of this area or all this area in the desert, because we need to make new communities for the people there and make the people make new lands and new cultivation. This is the schematic approach for the greenhouse production in Egypt. And we first of all, we select the proper location. After that, select the proper location near to the marketing. It's very important. And the proper greenhouse design and structure, proper nursery and wood stock, proper production of the vegetables and ornamental, and then harvesting and go to the post harvest and the cold store and marketing or exportation of the production. We import the greenhouses from many areas, collaboration with different countries for applicable technology under our conditions and creating job opportunities for many people in this project. And this is some of pictures from the project after start running and producing the vegetables for people. This is some picture also for the Ministry of Military of Agriculture and Arab Organization and Realization, cooperation with international companies from Netherlands, Spain and China and other countries also, because we need a proper structure, a proper techniques, what is suitable for us and suitable for different areas and different climatic conditions, because as a greenhouse, established greenhouse, not in one climatic condition but different climatic condition. And we start a different project in different area with climatic study about the proper structure of the greenhouse and proper construction. And our president also is very interested about this project, and he is following this project day by day, and to enhance the high yield and use the arable lands in Nile Delta and Nile Valley for producing the cereal crops and improve food security for people. So, what I said before. This is some pictures also. And we have a local manufacturer and installation belongs to the Egyptian Ministry of Agriculture, which have many efforts for improve the greenhouse sector in Egypt. This structure is a very common structure in Egypt, and this structure have some advantages and some disadvantages. The main advantages of this structure: cheap costs, easy to manage, easy for installation, easy for maintenance, and easy for moving from area to area and sell it. But this advantage of this system is not suitable for our climate, because this is very good for cold climate, but our climate is most of the year is not cold, but it's hot, and then we suffer, the plants suffer inside this structure from high humidity inside, low heating efficiency inside compared to the larger size, and difficult to enter the large tractors inside, and difficult to work effectively during the summer season, which makes this structure is not good for the continuous production under the greenhouse for vegetables and ornamental. And we started to move the more advanced structure. It is higher than the last one. The last one, the highest of the last one was 3 meter and 3 meter point 2, and this one is 4 meter point 5. It's more higher than 1.5 meter almost, and then you can make better management inside, and then you can cultivate easily and can manage environmental control better than the last one. And we can make side ventilation inside this one, higher ventilation for the plants, which makes the management of this system is more easy for the plants, and even the side of this structure is straight, and then you can cultivate all the greenhouse, not just a small area inside. And this is a picture for the installation of this side. We manufacturing these greenhouses and install it locally. We can produce it locally by many private sector, and even from the Ministry of Agriculture itself. It has the sector of the greenhouse which can produce such constructions locally. This is one more advanced for the make shading outside the greenhouse to can cultivate all over the year. When you become cold and you need more light inside the greenhouse, we move this shading, and during the summer we put this shading for the plants to protect it during our hot summer inside Egypt. This is a wood greenhouse which started to disseminate last 15 years in Egypt, because it's very cheap compared to steel greenhouse, and we make something inside these sticks to make it resistance for the soil moisture, and make the sustainability of this structure is more and more, and we become more and more expand this technique using wooden greenhouse for many reasons and many crops inside Egypt last few years. This is the local manufacturer and local fittings which produce inside Egypt, and also the fittings for the local greenhouse manufacturing. And this is some of the mechanical manufacturing for producing the greenhouse locally inside Egypt. And these different cover materials, we studied it, many studies investigated the proper greenhouse cover materials during climatic seasons in Egypt for many different climatic region inside Egypt to determine the proper greenhouse color cover. for different crops in different seasons in different climatic regions to determine the proper one for each one. The major crops inside the greenhouse cut flower and wood plants like carnation, aster, solidago, chrysanthemum, and the fruits such as mango, banana, grapes, and the vegetables like cucumber, pepper, and tomato, cantaloupe. And we started to producing the tropical fruit seedlings inside the greenhouse. We started from seeding, putting inside this plastic bag, and then after germination, and they started to grow. And after the grow, we make grafting for this one, and we produce many seedlings inside the greenhouse and export it outside Egypt, especially for Arabian countries. And it has become a good business for the private sector inside Egypt. And we start also from about 16 years to producing the dwarf mango cultivars under screen net inside Egypt. It is started like a study from 2009, and after 6 years the people started to adopt this technique inside the greenhouse because of climate change. Why we grow mango under the greenhouse? The mango yield decline last 5 years, very decline sharply because of the climate change. And during in 2021, the yield of local varieties was very weak, less than 10% of the usual crop, which causes heavy losses for the farmers. And a large number of farmers already started to cutting local mango trees such as Bedaya, Alphonse, Awais, Siddiqa, Sukkari, and etc. Imported cultivar varieties like Keat and Kent and others gave the production 50% of the usual production. New varieties planted under the net house was not affected like the outside. And I will show the procedures of cultivating the mango under the greenhouse in the next slides. Start with the climate change. We make the study for determine the heat waves during the from January till June. From January till June, it's the critical time for the production of the mango. Of the fruit set till June, it's still on the fruit till we harvest. If it's dropped during the from January to June, we don't have any crop. And then we found that from 2008, the heat waves started during the winter season, very higher and the frequency of the heat waves during the winter become higher and higher, even from April, May, and June. Last 7 years, from 2008 to 2015, start to more frequent of the heat waves in Egypt. And then the mango in the open field, it suffer from these heat waves and start to drop the new fruit setting and have no enough yield or no sufficient yield eventually. And when we make statistical analysis for the heat waves during the last 10 years, we found that it started to more frequent and more strong from 2008 till 2015. And when we looking for and make survey for the farmers inside Egypt, we found that some farmers don't suffer from climate change impacts like the other. And when we study who those farmers, we found that the farmers who cultivate mango between the dead palm trees. And then we start the point from here, this idea, and we can develop this idea by producing mango under the net houses for the small farmers and big farmers in the same time. And we start this study for 1 acre, and then it is adopted by the private sector last 7 years sharply. After 6 months from the cultivation, mango started to grow very fast compared to the open field conditions. And after 10 months from the cultivation, we found the mango started to flowering. And the practice started from the Agricultural Research Center during the 2006 and started to apply commercially in many farms by 2015. And during 2021 season, most of mango yield came from the protected trees, not from the outside trees, because it's protected trees not suffer from the heat waves like the other. The cover the greenhouse with the net makes the trees more more easy for the trees for the grow and the production without have any stress during the season. And this is the plants under the greenhouse also, some pictures of the plant, and this after 3 years from cultivation. And we follow the climatic data inside the greenhouse, and if we found there are a big difference from inside and outside. And this is after 4 years from the start of the cultivation. The plants started to give a very big yield compared to the outside. This is prepare the production for the marketing. And we start another study to determine the best cover material and the cover color for the greenhouses inside for the mangoes. And we found that the yellow and the white screen net is better for mango than the outside than the dark colors, because the mango need to sunlight rays, and the white and the yellow give sufficient sun rays and for the plants under the greenhouse, cultivated under the greenhouse. This is the greenhouse colors to test the best color for the mango inside the greenhouse. And we start to make a study for the difference between the climatic data inside the greenhouse and the outside greenhouse in terms of the maximum and the minimum temperature and the relative humidity. We found that the maximum temperature decreased under the greenhouse by 2 to 3 Celsius and during the day, and the minimum temperature increased inside the greenhouse by 1 or 2 Celsius. That makes the weather started to become more good for the plants, because the mango, we know it is a tropical fruit, and then it's not need very high temperature or cold temperature during the night. And then the screen net protected the mango from the stress during the day and the night. And when we study the relative humidity inside the greenhouse, we found that the relative humidity inside the net house higher than outside by 4 to 8%. And diseases make the condition inside the greenhouse started to better and better and more suitable for mango trees under the net house. And this is economical study for the control. It's an open field condition when you producing the mango outside, and then after the 2 years we have no yield outside, but inside the greenhouse it start the yield from the second season, and then the faster return of the infrastructure of the project, and then you can make a profit after you cover the seasonal costs, and you have a sufficient profit. Soil culture inside Egypt. Egypt started the soil sculpture technique from the 18th of the last century, and it developed inside many countries, and our professors started this technique very early, and we use this technique for solve some problem inside some farms, such as nematode and soil-borne diseases. And this is very simple greenhouse soil sculpture technique. We called it open soil sculpture system. We have black bag, and we put this substrate inside this bag and cultivate the vegetables and make something like sheets, plastic sheets, to protect this from the soil, and cultivate the plants, and the plants grow very good inside this greenhouse and good commercial production. And this simple technique is very easy even for the small farmers, and we make many training courses for people to learn them, to teach them how about adopt the cultivation inside the bags and something like that, instead of the soil, because of the soil problem, avoid the soil problem. And this is the system, open system. We don't collect the soil, the water, and pump it again. Water pump it for one time. And this also, some pictures for soil sculpture and simple technique, and it gives high yield and avoid soil-borne and disease with reasonable cost. And this another techniques inside Egypt, Egyptian technique 100%. We started to different bags and to cultivate tomato, and the tomato can grow and have a good production without any problems. This Dutch bucket and another techniques also inside Egypt, we develop it inside the Agriculture Research Center and the Ain Shams University. They learn this technique, and we started to develop this after them. And this is, we can sell our product for the local market with a very good price, and we can cover the cost of the production. And this is the tower for lettuce plants. Leafy plants is very good in these techniques, and they give a very good production with reasonable price. And this is some of the commercial farms, private farms inside Egypt, which cultivate leafy crops for the McDonald's and something like that, some restaurants like that, because these restaurants have shortage of the lettuce and the leafy crops during the summer, and they was import the lettuce and the leafy plants from outside, and the Egyptian private sector started to develop this technique with the researchers from different areas, such as Ain Shams University and Agriculture Research Center professors, and started to develop these techniques, and started to provide the local market with the lettuce even during the summer season, and cover our local needs. And this is the private farm. It's called agrimatic farm. This is aquaponic system. We grow fish and producing the plants, and the fish and the plants give a good production. And this farm is sustainable and maintained for 10 years, and then it have a good profit from this production. They make a system, we call it deep water culture. It is very easy system for manage, and we make this system work very good for 10 years now. They bring the water from canal, and then go there to the sedimentation ponds to clean the water from any residues, and then the mechanical filtration, and after that ultraviolet sterilization before the water go inside the aquaponic system, inside the agrimatic farm. And then this is fish pond, fish basins for the basins, and they incubation this basin with nitrosomonas bacteria for convert the ammonium nitrogen to nitrate nitrogen. Nitrate nitrogen is not harmful for the fish, and then can make the water circle again and again and again, and then they make the nursery for the production during all the years, because they producing the during even the off season. They producing these leafy crops even during the summer, and this is a greenhouse. They make the ventilation and the cooling system inside this greenhouse, and producing different types of the leafy crops for the local markets which need this type of crops. And inside our project, we established environmental control greenhouse powered by solar energy and operated remotely with mobile application. It includes indoor and outdoor agriculture, fish and animal production. Professor Abdelazim Nek will deliver more details about these benefits of this integrated system. Computer software for fertigation management, which produced by the Ministry of Agriculture. And we start this work with determine the irrigation requirements under the greenhouse by install the EBAN inside, evaporation ban inside the greenhouse and outside, and determine the relation between the evaporation ban inside and outside greenhouse. And the Professor Abu Hadid et al. 1988 make a mathematical model for this, and Dr. Abdel Hamid Hashim developed this work during the 2012. And this is the experiment inside, and we started to recording the climatic condition inside the greenhouse to determine the irrigation requirements inside the greenhouse. This is climatic data in the Gazik area, and the evapotranspiration inside this during the year, different months in year. And this is the weekly irrigation water requirements for each plant by liter per plant per day during the different weeks from the inside the growing season of cucumber, which cultivated inside the greenhouse. We programming this tabulated the irrigation requirements for the farmers to make the management is more suitable. This is the different crops inside the greenhouse and the life period for each one, and the average irrigation requirements liter per square meter per day, and the suggested growing season. This is helpful to make the planning for the farms and be sure the for water resources is quite sufficient for crop needs. This is the number of plant per square meter, and the yield by kilogram for square meter, and water use efficiency. We found that the leafy crops has a higher water use efficiency than the fruit crops, vegetable fruit crops. And this is the program for fertigation management inside the greenhouse. This program funded by Ministry of Land Reclamation, Agriculture and Land Reclamation, and this program is available for free inside Egypt. And this program has intellectual right license from Egyptian government. This is a systematic approach from the program. We collect the data, climatic data, plant data, soil data, and then we calculate the irrigation requirements, and then we calculate determine the crop needs from different nutrients, and the plants make photosynthesis, and we make the tissue analysis to ensure the tissue analysis or the content of the different nutrient inside the tissue is quite sufficient for the plants. And then we determine the optimum fertilizer application and make fertigation program for the farmers. And this is the main screen of the project of the program. The program has two interfaces: language, English and Arabic. And we made continuous training has been done for during the last 6 years for graduated agriculture engineering and for some people from other countries for this program. And this program is very successful for determines irrigation and fertilization requirements. This is main forms. We select the farms and they put some data related to the area of the greenhouse, the plant population, immediate discharge, irrigation efficiency, and so on. And then select the crop you need to determine the irrigation and fertilization requirement, and the months what you need to cultivate, and the age of these plants. And then the program asks you for the plant analysis if you have. If you don't have, the program will put the optimum one, and you can enter the soil and water analysis for the program. If you need this. Hi, something wrong?
عملت ايه؟
Hi, something wrong?
No, continue. Yes, please mute your mic. Continue, Dr. Muhammad.
Okay, Doctor. And after you input this data, the program started to ask you for the fertilizer available for you, and he gives the active ingredient of different fertilizers. And even if you would like to put the another fertilizers or compound fertilizers, the program
بديني فكرة
هو فيها يا دكتور. And if you would like to add the compound fertilizers, it is applicable in the program. And then the program started to give you the recommendation about the irrigation requirements and the different quantities of the fertilizers which you need to inject inside your system. And you can print this data, and you can have grant chart of this data. And then you calculate the irrigation and fertilization requirements for the greenhouse. And even if you would like to make fertilizer management for all greenhouse, not for one greenhouse, and how many times you will inject each kind of fertilizer, the program can help you. And even program can give you a grant chart about the doses of fertilizer you added during the current week. We made the training for small farmers in different area for many years for the farmers. This training is very important to providing the protected agriculture sector with a proper technician, which you need almost all the time. And we make collaboration with Punjab University to collaborate and change our experiences together. And the conclusion of my presentation: protected cultivation of horticultural crops in Egypt had significant developments in many aspects. The national project of 100,000 greenhouse has been one of the major motivations to improve the protected cultivation sector during recent years. There have been significant trials for both commercial and the research sector in terms of improving greenhouse production and using new technologies such as soil culture and producing tropical fruits under the greenhouse. Improving the knowledge of the people who work in the sector is really a challenge till now, which protected agriculture faces the availability of new technology and advanced techniques, and then continuous training considered a vital issue for sustainability of the greenhouse inside Egypt. More effort is still needed for every subject mentioned in this presentation. for improving the greenhouse and environmental control of the greenhouse and producing the vegetables. The acknowledgement, this interactive training webinar is based on work that supported by Science, Technology and Innovation Funding Authority, STIVA, of Egypt, grant number 3.771, and the British Council of UK, grant number 332435306, through the project titled A Novel Stand-Alone Solar-Driven Agricultural Greenhouse Desalination System that grew its energy and irrigation water via a Newton Musharrafa funding scheme for the purpose of training and the attendance and stakeholders of the current Egyptian greenhouse practices to consider the best practices in Egypt. Thank you for attention. If any question, welcome.
And thank you so much, Dr. Abdurrahman, for this very interesting presentation and very informative. Let me suggest that we, well, maybe take one question now, and then what I'd like to do is save all the questions for the end, and then go straight to the Dr. Abdelazim's presentation. So, but if there is one.
Muhammad, can you stop sharing?
So
Yes,
Adina
yes,
Payton
yes.
has a question. Do you, and so please, Adina, if you'd like to ask your question right now while Dr. Abdelazim is preparing his slides.
Shall I stop sharing?
No, I think you could keep sharing. I tried to make it possible for Adina to speak, but maybe that was unsuccessful. Well, tell you what, Adina, why don't we go ahead with Dr. Abdelazim's talk, and then we'll start with you after he's finished. So please, Dr. Abdelazim.
Okay, welcome. Well, thank you for giving us this great opportunity for sharing our research ideas and work in this international series of webinar of the Center of Excellence of Water that funded by USAID Egypt. I tried to make the slide screen, but it seems that it is not moving. So I will keep this screen if you don't mind. This is my bio. Most of the people knows I will keep the presentation, so no problem. You can check it later. The outline of this presentation, I would like also to save time. I start with the same question Dr. Muhammad asked, but I will not answer it because I copied the same slide, same reasons why arid and semi-arid countries are interested in greenhouse. Egypt, of course, are arid, but it is also classified as hyper-arid because we are suffering from water scarcity. So, but some people still classify it as arid. But based on the international level of scarcity, Egypt are suffering from scarcity of water. Second thing, we'll just mention that there's a good study about greenhouse making gap analysis. Then I will go, we'll ask this question, are technological greenhouse needed? And the other question, are the technological cost, are the technological greenhouse cost justified? What are the Zagazig University's technological greenhouse components? Then we'll go quickly to long-term benefit of the technological greenhouse of Zagazig University. I will use TG for technological greenhouse and ZDU for Zagazig University. Then I will where the TG of ZG could be ZDU could be implemented. What are the locations in Egypt? Then conclusion and recommendation. So this is the same slide. Dr. Muhammad started by it. I copied from there instead of I print another because it was very nice slide. So this is the reason. Already he presented this, so I'll not present it again. Because greenhouse are good for food security, for safety, capacity building, welfare of Egypt, social issues, etc. In this study which was conducted in 2017, and this is DOI number. I can share with you. It is available on the internet, no problem. Anyone could write protected horticulture in Egypt. Can download the study. It is a state-of-the-art review of the horticulture in Egypt. Actually, it is presents very good points. One of the ones that we need to develop more techniques, technologies, and we need to use technological greenhouse in Egypt to increase the monitoring brackets, how to move the monitoring brackets and decrease the productivity and control the microclimate. So for this reason, we started our project in Zagreb University, which is funded by STDF and the British Council. So before I start, I would like to ask, are the technological greenhouse costs justified? Because it involves many costs, especially for research and development, not only for production. So I could answer this as for the pilot system, as the one in Zagreb University. I can answer no. It is not cost justified if used for production due to the relatively high relative and development cost. But if it is constructed for production on large scale, yes, it is justified. Why our ZDU technological greenhouse is justified, although its production is very small, because the pilot system can help in improving the education quality of the agriculture student, particularly the horticulture department student, crop department student, animal production student, soil and water science student, and the agriculture engineering department student. This means it works as a research laboratory and educational laboratory as the Faculty of Agriculture. And this is one of the reasons why we selected the location in the agriculture and the Faculty of Agriculture to keep it sustainable research station for more than 5 departments in the Faculty of Agriculture. Then the system also could be help the stakeholder to investigate the challenges causing a reduction in the production of the greenhouse and offer solution based on microclimate condition in the control system. I suppose that in the existing greenhouse, there is some problem facing the farmers and the owner. Then we can receive these problems and try to find solution under our climatic control in our greenhouse. The pilot system could scaled up to different places in Egypt where fresh water and or brackish water is available with minor modification according to local climatic condition and environmental condition and the availability of water and its quality. All these benefits could make the system economically feasible if we could calculate their monetary values based on this. But if we only calculate the production of the pilot system, which was built on 100 meters square, of course, it is not economically feasible. But this other benefit make it strongly feasible because building capacity of the people is worth too much. So what are the components of the technological greenhouse in Egypt, in the Zagazig University? It is an integrated water, energy, food, environment system consisting of water component, fire desalination subsystem. It is also include energy component, fire, solar energy subsystem. This means that solar energy is clean energy, no pollution, no carbon emission, so support the climate change. And some third component is food component, because agriculture, and it also includes automatic irrigation subsystem. So food is produced, and modern irrigation system is used just to save more water. The fourth component is environment, because it is designed for zero residual. Because the irrigation system is modern irrigation system, so no need for drainage, and the solid waste, the existing solid waste could be used for other products. Maybe some of it we use for feeding the animal. The other residue could be used to produce biogas. So the component of the waste management is under construction. So it's cost only for a small scale for this pilot system about 20 to 30 Egyptian thousand. 20 to 30,000 Egyptian pound. So we request the university to accept our request and give us fund from the project money to implement this component. Technology, because the system is have sensors and have monitors to present the values of the sensors, and have a mobile application. We can operate it from any place, the monitor the system from any place. So we have 5 components, because the system is a technological greenhouse, but it is not fully automated. We plan in the future to just the ventilations opening. It is still not fully automated. In the future, if we have fund, we'll convert it to fully automated. Then the system will be fully technological greenhouse system. All of these components are worked, are integrated together in harmonic, so it is easily monitored through the available screens. So I mentioned before the long-term benefit of the technological greenhouse in the cost justification, so I will not repeat it again. I would like to mention how the technological greenhouse of ZDU could be implemented. It is mainly designed to be implemented on any remote area, but provided that this remote area contains either fresh water or brackish water or saline water or even seawater, plus any source of energy, either solar energy or wind energy or combination. But it will be some location who is no match with this if no groundwater is available, or no sunshine, or no wind energy. So we could not present this system, but we could present the ordinary system, maybe because energy by any means is highly recommended for the operating of the system, particularly if we need energy for pumping the water and for the operation of the technological component. The other question are the TGs connected to water, energy, food, environment nexus. I could safely say yes, because as with the previous slide, the TGs are producing water and use water with higher efficiency, as Dr. Muhammad said. TGs are using solar energy and save electricity and hence reduce carbon emission. TGs produce agricultural food of different kinds for direct eat or for industry to increase the value of the product, added value. TGs are environmentally clean or eco-friendly with minimum carbon emission with no waste management. And if we have waste management system, then we have zero carbon emission from the system due to use of means of fossil fuel or emission emitted from the waste without management. This means that the different components are there, which are water are there, energy are there, food are there, environment are there. So we could conclude that this pilot system is a typical perfect system to apply for water, energy, food, environment. Is it possible to apply? Yes, it is, because in the water, energy, food, environment system, there should be some methods to implement the Wi-Fi system. We have in this project modeling approach, 1D and 2D modeling approach using CFD. It will be there in the publications. I will not present here, but I list it at the end. We have also experimental approach. Agriculture expert team are making different experiments on the different crops indoor, inside the greenhouse, and outdoor. It means outside the greenhouse. Also, with our expert, Bروفيسور Basuni, makes the feasibility study and economic assessment of the pilot system. And as I told, due to the high R&D, it is not profitable for production, but profitable for other means. But the business model is profitable. Technological approach for monitoring. This is could be monitor everything to measure the efficiency of the different components. And we have the waste management system, which we could, if we could analyze, then we can conclude how much carbon emission is saved. And all this means that the greenhouse or technological greenhouse are good means to mitigate climate change impacts by saving more water for other production, increasing the food production, cleaning the environment, etc. So I am approaching the end by this question: are the TG connected to SDGs? I will not go deeply in this because I presented it in the previous seminar, maybe in March seminar. The answer is yes, and I'll present this slide that indicates that in the inner circuit, water and energy and food are there in direct support to the SDGs, but in direct we have other SDGs in the second cycle and in the third cycle. So we can conclude that the water, energy, food, environment system actually supporting directly or indirectly the 17th SDGs. The last one is partnership. We have a different partnership. We have Egypt and UK and several institutes from Egypt. All of these are in partnership to develop and participate in this system, and producing a huge list of paper and publications related to this system. My conclusions and recommendations are technological greenhouse is a perfect water, energy, food, environment application. This is, I am opening the door for research on this analysis of this kind of application of Wi-Fi nexus. On large scale, technological greenhouses are very useful as an ideal research and educational labs. In addition, for production, this is on I think this is on a small scale. Sorry, small scale or wide scale. It is very useful for research and education and consultation. On a larger scale, it is perfect for production and could be used for climate change mitigation, as no carbon emission, saving water, increased food activity, etc. So TGs are very connected to SDGs and serve many of them. So I will end my presentation with the project publications. It is, by the way, this is the website. I invite all of you to visit the website of the project to see how much the team achieved many research work from this project. So this is a lot of publication. This is a 19 publications, and also we produce some books. But I would like to mention that we were selected as a success story from the British Council due to the big achievement and the effect of this project on the mitigation of climate change. This is some of the produced book related to the state of the art of the topics related to our projects. Some of them about the desert environment, because we need it to implement the project. Some of them about the agriculture and sustainability of the agriculture and irrigation, modern irrigation, and Western desert. By the end, I would like to acknowledge the funder with the British Council and the SDDF, which is now STIFA, who funds the project to offer standalone solar-driven agriculture greenhouse desalination system that grows its energy and irrigation water. And all of your questions are most welcome. I think this is the end.
Well, thank you very much for that very informative presentation, Dr. Abdelazim. And we do have time for a nice discussion about the importance of greenhouse gases and their relationship with climate change and how to improve the very beneficial nexus between food, water, and energy. And so I'm not sure if we can enable for the participants the sound for them to speak. But if you look at the bottom of your screen, you'll see something that says Q&A. At least on my screen, it's right near where it says share screen and so forth, raise hand. And so if you can write your questions in there, or you can write your questions into the chat. And if you raise a hand, we will make it possible for you to speak. Okay. Yeah, I would like I would like to allow people to speak if possible. Oh, so Maggie Magars asks, where can we find the books and the papers and the research you presented at the end? And this is a question for Dr. Abdelazim.
Yes, with pleasure. If you visit the website www.smart/horizontal/gh from greenhouse.net, you will find all the papers and the materials, book chapter and the books. If you could not download from there and you are Egyptian, you could easily download all the books and the chapters from the Egyptian Knowledge Bank. Please go to the Egyptian Knowledge Bank. If you have account, it's easy to go to Springer website inside the platform of the Egyptian Knowledge Bank and go to the PDF box or e-books and search for the title you like. Already the name of the books are in the presentation. Then you can search for the needed book and download it for free.
So maybe
all of the resources on the Egyptian Knowledge Bank are for free for Egyptian scholars.
Maybe you could write that website into the chat.
Yes, of course. It is already in the presentation, but I will write it again.
And I think Adina Payton had to leave the meeting just a moment ago, but she asked me to ask a question of Dr. Mohammed.
Yes.
And her question was, how are you integrating the energy side of food, water, energy into your greenhouse gas? I mean, not greenhouse gas, your greenhouse experiments, because the food part, the water part are very closely aligned, and then the challenge remains with energy, and you're doing some really interesting work there. And could you please talk more about that?
The weather in Egypt most of the year is hot weather. The winter in Egypt, it's almost January and February, only January and February, and then we don't need a strong cooling system inside the greenhouse, and then the energy we need, it's not high for such greenhouses for vegetable production. Just the greenhouse for lettuce in the summer season, we need higher energy to make cooling for the greenhouse. We don't need make in the greenhouse heating. We just need the cooling system. No need for heating system. Only cooling system during the summer. And if we don't produce the crops such as the lettuce considered one of the winter crops. I think everybody knows that. And then when you try to produce lettuce during the summer, you need to make the temperature around 25 Celsius. And it's exceed 35. And then you need to reduce the temperature by almost 15 degrees. And then we use the simple cooling system. And this system is very effective for cooling the greenhouse. You talk with me about the water. This what I talk about the energy, about the water. The greenhouse saves 30 to 40% of the water compared to the open field for producing the same quantity of the production. But the soil culture techniques, especially the hydroponics, it saves about 80% of water. And then we adopted these systems for make higher production from the water unit under the greenhouse. In the other hand, we try to cultivate all this production in the desert because we don't like to construct the greenhouse in the arable land in the Nile Valley and the Nile Delta. And then we leave bigger areas for cereal crops and enhance the food security for Egyptian people.
Thank you. Thank you.
Just Just one comment. Because water, energy, food system are complicated. Actually, we open the door for other researchers to use our results to make a comprehensive and studies and investigation about the integration of the system. Because still the systems, technological greenhouse in Egypt is still new. So actually, we open the door for other research and investigator to start making a comprehensive analysis of the water, energy, food system and the water, energy, food, environment system. Thank you, Dr. Muhammad, for.
Yeah, thank you.
You're welcome.
So Mahmoud Sultan has his hand up, and let's see, Dahlia, if we can make the make it possible for him to speak.
Yes.
First, thank you very much for our esteemed Professor, Dr. Muhammad Abdrabbu and Dr. Abdelazim. Really, I am appreciated, and it's very informative presentations, and I am happy to be with him today. This is the first time I hear about them, but this is the first time to attend webinar with them, but I think I will be eager to meet them in person nearly. So you talk about saving water, and really this is impressed me because this is my work, and I work in the same place with Dr. Abdrabbu in Agriculture Research Center, but in different departments. So we didn't mention about grafting as a way to save water and also save and I think Dr. Abdrabbu know that grafting is a new technique in Egypt. I think it's not a new technique, but become a popular technique that be used in all greenhouses. So, and I think based on different rootstock, we can save maybe 50% and can reach to 75% of water can be used. Thank you very much, and I think I appreciate what you give today. Thank you very much.
Thank you, Dr. Mahmoud.
Any thoughts or additional comments?
I have comment for Dr. Mahmoud. I started to thank Dr. Mahmoud for his valuable comment he talked about, and what he said is true. The grafting of the woodstock and the seedlings in Egypt is a really good challenge or big challenge for us. And some private companies started to make such woodstocks for the Egyptian market, but it's still not big like the enlargement of the greenhouse system in Egypt. The greenhouse system is still bigger than the efforts, and I think with time the grafted seedlings will be the priority for the farmers, because it's from one hand it is very good for the soil-borne diseases and protect the plants from the nematode and the saline conditions, and from the other hand it's really more water use efficiency than the without grafting system. Thank you for all.
Thank you, Dr. Abdrabbu, and I think it's very informative. But I think grafting, despite I finished my PhD in the US at the Ohio State University, my PhD was about grafting, and I think despite they didn't have more problem like biotic or abiotic stress, I think they improving grafting as a technique for the future. So I think as you as a leader in Egypt and Dr. Abdelazim, I think we should think about this as a project or to involve this, and I think we can collaborate in the future. Thank you very much, Dr. Abdrabbu again, and thank you, Dr. Abdelazim. Thank you.
Well, so happy, Dr. Mahmoud, if you could agree to visit us at the location of our project and advise us as much as possible, then we'll promise you that we'll implement any of the best practices you advise us to implement. Thank you so much.
I think I will visit, but I think I need the information, please, Dr. Abdulazim, and I will visit you soon, inshallah.
Yes, Dr. Muhammad is a member of the project, and we'll invite him and you shortly.
Okay, thank you very much. Thank you very much.
Wonderful. This is exactly why we hold these webinars. And I saw that Darwish Saleh had raised his hand. Do you still have a question?
He lowered his hand.
No, please give him the mic because he's a big professor from Cairo University. Will get benefit from his talk. He's working on water, food, energy, food ecosystems.
He's not in the meeting anymore.
in a big project in Brima.
Oh, he left the meeting. Oh, well, okay. Well, I'm glad he was here to listen. And I noticed that Imad had a hand raised. And so why don't we go to you next?
Okay, you hear me?
Yes, Doctor. Yes,
I am Imad from Palestine. I would like first to thank Dr. Abdulazim and Dr. Muhammad. And I would like to ask about grafting. The rootstock that you used, it is the local rootstock or commercial? First question. The second, if it is commercial or local, you have a rootstock for bacterial diseases or not? Thank you.
Allow me to answer Dr. Abdulaziz, Dr. Abazim.
Please.
Yes, the rootstock we use is imported from outside for different crops because it is not available in Egypt, and we import different rootstock for the carbita and the solanacea, and it's not big disseminated in the commercial purpose. Till now, it's not. I can tell you the grafted seedlings is not more than 1% of the total seedling we use till now. And then I am agree with you and Dr. Mahmoud Sultan. We need a very big effort in this issue because the international system, all of the international system use grafted seedling for many reasons. And you said, and Dr. Mahmoud said the reasons why we select the grafted seedling more than the regular seedling.
Thank you.
Thank you. And I see that Ghada Amir has written a question in the Q&A, and she writes, Dr. Muhammad, we need to know the name of the program which calculates the amount needed of fertilizers in the technological greenhouses.
It is called 30 greenhouse CLAC. 30 greenhouse CLAC. CLAC is a central laboratory for agricultural climate, and this program is available for free inside Egypt. Anybody visit me in the central laboratory for agricultural climate, I will give him the program, and if he would like to know something about this, I can explain. It is easy. I do that for more than 15 years till now, for everybody.
Is it possible, Dr. Muhammad, to integrate it with our system? Because we have automatic irrigation system and a system for fertilization and fertigation, and we make some program to make this, but maybe if we could use the advantage of your system, because I attended several presentations for you. I find this is very efficient. So maybe we can also use it in our greenhouse instead of our system. Yeah.
I appreciate that, Dr. Abdulazim.
Let us try it. Let us try it and compare which one is more efficient. Then we adopt the most efficient one. Thank you so much.
You're welcome.
All right. Next question from Oh, and here's from Mahmoud Sultan. Thank you very much. Could you please send the contact information for both Dr. Abdurabu and Dr. Abdulazim? And perhaps could you write, if you haven't already, just write into the chat your contact information?
Yes, we can. I can do.
That would be great.
Yes.
My mobile number. It's okay. My mobile
Excellent.
number.
Yeah, that would be great. And now here's a question written from Samet El-Sawi, writing, please explain how smart agricultural technology can save irrigation water and fertilizers.
Okay, sorry.
So how can smart agricultural technology save irrigation water and fertilizers? And for example, it looked like irrigation water was down 20 to 30% in the greenhouses. And so how are you able to achieve those really dramatic reductions in water use and also reductions in fertilizer use?
Allow me, Dr. Abdulazim, to
Yes,
answer
please.
this question.
Yes, please, please.
First of all, under the greenhouse, the relative humidity is higher than outside by 30%. It means the ability of the plant to make respiration is lower than outside. And when we talk about the water consumption, we don't say about the water consumption per plant, but we talk about the water consumption for 1 kilo of production. That's what we're talking about, the water use efficiency. If you would like to produce, we calculate the cubic meter of water produced, how many kilos of cucumber, how many kilos of tomatoes, how many kilos of lettuce. And then when we compare the inside greenhouse and outside greenhouse, for the such as tomato, the water use efficiency 1 cubic meter inside the greenhouse produce almost 17 kilograms of tomatoes, but outside it's produced 4 kilograms of tomato. And when we talk about the smart agriculture inside the greenhouse and the water and the fertilizer, we use the climatic data in the beginning. And the climatic data in the beginning allow us to give the plant the accurate quantity of water which needs. And then we don't put more water or less water. And then we take a proper quantity. And moreover, under the smart agriculture, we use soil culture techniques. And soil culture techniques, we circulate water under the the plant roots, and then we don't have any water losses. And then the water use efficiency for tomato under the greenhouse for a cubic meter produce more than 30 kilos of tomato. And then you can compare these figures and you know how much you can produce inside the greenhouse by 1 cubic meter of water. The same about the fertilizers, because we use a fertilizer in the hydroponics more efficient than the outside, because the fertilizer is still inside the circulating system. We don't lose any of fertilizer. The plant absorb all the fertilizers we added to our system without any losses. Thank you.
Very interesting. I wonder, let's go to Dr. Hisham Mohammed El-Basouini. And Dr. Hisham asks, does your program have any technical way to suppress the insect infestation in the greenhouse? So, yeah, how are you dealing with insects?
In the greenhouse, we use the IBB system, integrated pest and crop management. And then the beginning of all, inside the greenhouse, we started to try to avoid the insect to go inside the greenhouse. How we do that? Because we cover all the greenhouse with insect-proof nets. And after that, we make traps for the insect. If the insect also come inside the greenhouse, we calculate the infection. If the infection is not significant, we don't use chemicals. We just use sulfuric. And if it is become reasonable, it's okay. If not, we started to spray chemicals. But if you use integrated crop management inside the greenhouse, we will use very low chemicals, especially in the soil sculpture techniques, because we inside the soil sculpture technique, we have to implement the integrated management inside the greenhouse to proofing insect infection inside the greenhouse.
Thank you. If I might ask a question, this is for both of you. You've talked about this very interesting research program, and also how many students you have brought in to teach them and train them on the system. And I wonder if you have a broader training program with commercial or large scale farms where you are training and transferring this technology into use.
Muhammad, shall I answer?
I can answer, yes. The reality is I am member from the trainers of the national program for the greenhouse, 100,000 greenhouses. And I really make training, special training for the agricultural graduated engineering for more than 10,000 graduated engineering for 6 years. And most of them become my friends, and they ask me for more training after that. And I do the same training inside my laboratory. But the further training, they pay for it. But the first one is for free, second one for money. I have to pay almost $25 for the training. And the total of the trainers I did for the people I train, almost 10,000 persons, maybe more.
Wow.
So we would like to invite you for our training program for the stakeholder and the farmer in Zagazig University. So we'll pay for our 500 Egyptian. Is it okay for you?
I'm honored.
It is very low. It is very low money, Dr. Abdelazim.
Shall we seek for another one?
You should charge more.
Yes.
I'm joking with him, because he is a member of the project. We should train the people for free.
And one of the attendees has asked, can you use percentages to describe the water savings for the types of crops you have used in your greenhouses?
For me, I can answer also. In the beginning, we started greenhouse from the 18th of the last century, and in the beginning of our work, we were looking for the comparison between inside and outside. And after 15 years, our professors and our masters stopped to do that, because we found there's a big difference between inside and outside, and we don't make such a comparison, because it's like old fashioned. We started to comparing between two things very different, and the different areas we talk about, and then we started to compare between different systems. If you use soil sculpture system, if you use drip irrigation system, if you make the modification of the climate inside the greenhouse, how much water and fertilizer will plant take, and then we don't compare with the open field, because even the seed we use inside the greenhouse is different than the seed outside. There are particular seed for the open field cultivation, and another seeds for the same plants inside the greenhouse, not the same. And then the comparison is not good. You compare between two different things. But in terms of the water saving and water use efficiency, I talked before about the figures between the inside the greenhouse and the outside the greenhouse. And many even different countries, and we share our knowledge together. They do the same, and I think the same figures, not big difference between our figures and them figures.
So Ahmed Shaban has asked, again, where can we find your publications and research on this? And there are a couple of ways I'll mention, and then maybe you can both mention, because we've already discussed it a bit. And one way is that the Center of Excellence website will publish the presentations, and there are references in the presentations that can get you to the our materials. And anything else you'd like to add on that?
I suggest I will write my scientific name for them. I published not like Dr. Abdulazim. Dr. Abdulazim published more than me, many. And I will just write my scientific name, and he can looking for my scientific name in the web system, and he can find all my publication. My publication only 160 papers.
Too much.
Only.
He said only. We wrote together some papers. I cannot remember, maybe 3, 4, 5 papers. All of them are also on the website of the project.
So what they're saying, Ahmed, is that you need to build a bookshelf since you asked for these publications. And then you can collect them.
I wrote my scientific name for people, and who would like to looking for my publication. My publication, most of them in greenhouse, water and fertilizer management, something like that in this field.
So they could write just on the Google Scholars and the name written by Dr. Muhammad.
Yes.
Or Google citation and the name. Then the Google profile will come. You can check there and download the papers.
And before we get to another technical question, I have one for our technical manager of the webinar. That's Dahlia. And Dahlia, many of the participants have put their email and contact information into the chat. And it seems to me that it is becoming a very valuable network of people interested in greenhouse research and use of greenhouses in actual farms. And so is it possible to take the chat and turn it into a contact list on this subject that everyone can share? Because that would be a nice way to build the ability for this group to communicate.
Yes, if they are all okay, of course, to exchange their emails among each other. So fine, yes, we can do this and send it to the participants.
Okay,
yeah.
Well, that would be great.
We asked Daya for this for the last seminar. She said it is not possible to share the contact information of the attendees, although we are the people who are invited the attendees, which feels strange for us. She did not to share the information with us.
I mean only the emails, Dr. Abdulazim. I will share only the emails, a name and the email, and they can exchange it between themselves if they are okay with that.
Emails and the names.
Yeah, but personal information, who is coming from where, background, the personal information, I cannot share this. Mobile numbers, I cannot share this.
Of course.
That's a good start, though.
Okay, thank you so much.
Yeah, thank you. That will be very helpful. And so a question of a more technical nature is, it has to do with the high relative humidity inside of the greenhouses. And have there been any negative side effects? And how have you dealt with that?
Dr. Abazim, allow me to answer.
Yes, you are our expert, of course. I have only 2 years expertise in greenhouse, but you have 30 years maybe.
Thank you, Dr. Abazim. we make different ways for ventilation, but the most effective way is natural ventilation of the greenhouse. It is very important, even during the winter, because not just the humidity we try to reduce inside the greenhouse, but also we need carbon dioxide to come inside, because the plant wants to make photosynthesis, and then we have to refresh the air inside the greenhouse. If we don't make air refreshing and they put new air, then the carbon dioxide become low, and the photosynthesis inside the greenhouse will be stopped. And we have to make ventilation. And when I talk about the greenhouse structures, different structures, I said that the old structure is very poor because the ventilation is not good, because the ventilation just from the two sides of the greenhouse. And then we go to the another greenhouse structures, more advanced, to provide the greenhouse with sufficient ventilation system for reduce relative humidity inside the greenhouse, and then the plant started to absorb water from the soil or the substrate, and also refresh the carbon dioxide inside the greenhouse, and the plant started to make photosynthesis and build the dry matter and give good production. I answered.
Thank you. Walid Shakwir has asked two related and important questions. And one is there a specific region in Egypt where climate change has, it's clear that climate change has affected the crop structure, or do we have some evidence of the impacts of climate change in any particular regions of Egypt? That's the first question.
We recording the mango, such as mango and the citrus. It's declines the productivity of mango and citrus because of climate change, because the flowering and the fruit setting consider a critical stage, critical phenological stages for the mango. And then during the flowering and the fruit setting, this is during the months from March till the June. And then when the extreme weather events started during this period, most of the production of the fruits started to decline. That happened very sharply during the 2021, last year. And for mango, some of farmers don't have any yield, zero yield, because of the climate change. The same about olive, the same issue. About the vegetables, tomato price this year is very high because of extreme weather events. It was not exceed $0.2 for 1 kilo, but it's exceed $1 for kilo for last 3 months, and that because of the climate change and extreme weather events which declines the productivity of the tomato outside the greenhouse. The greenhouse relieves these issues because it's cultivate. It relieves the extreme weather events for plants because you can control the climate or the environmental control inside the greenhouse and the smart system. What Dr. Abdelazim talking about, it is very important because I have many tools for climate modification inside the greenhouse, and then I can reduce the sharpness of the extreme weather events inside the greenhouse, and continue the good production even during the extreme weather events.
Thank you. A question has come in from Abdul Wahid Syed, and it has to do with the sensors you're using in the greenhouse. And Dr. Abdul Wahid is asking specific to soil humidity. But if you want to discuss a little more about what you would say are the essential sensors that give you the data you need to manage the greenhouse, that would be very interesting.
We're using the sensor called thermohygrograph. Thermohygrograph. It is now available in very cheap cost in the market. I think it's about $50 for each. And $50 is not a big money. And also this device can recording the data for 1 month. And then he can install this thermohygrograph inside the greenhouse and take the data from it. I work in the Central Laboratory for Agricultural Climate, and then I advise this guy, if he buys this device, he should to make calibration every year, because maybe the sensor reading started to not accurate after 1 or 2 years. And then if he buys something like that, not trust the readings all his life. After 1 year can make calibration, and the second year calibration, every year make calibration. And we also when we make our studies, we don't put thermohygrograph, we put automated weather station. Automated weather station with all sensors, solar radiation sensor, thermohygrograph, wind speed sensor, all sensors. Complete weather station, automated weather station, and it's recorded all the climatic factors, not just relative humidity or temperature.
Could you please write thermohygrograph?
It's okay. It's okay. I will do. Dr. Brent. I will do.
Thank you. And would you say, are there any other key sensors that you depend on that you'd like to talk about? You know, in other words, what makes the smart greenhouse smart? What are the sensors you're using?
I think Dr. Abdelazim can
No,
answer this.
I don't remember now the sensor because the data sheet was not with me. Tomorrow I will meet the company and will receive all the catalog and data sheet for all the instrumentation and equipment. At that time, I will make a list for everything. I will post them on the website. Actually, I don't have, because we have about 20 sensors. Each group sensor for one parameter, for temperature, for relative humidity, for wind, for soil, for etc. So I cannot remember the model and the names.
Thank you.
Because the team I have a big team. One of the team member is concerning for this part. I have one for IT and communication system, another one for desalination, another group for agriculture, etc., etc. We are many people, not only one. Dr. Muhammad are our specialist in the greenhouse.
Yes, I remember. I just want to emphasize one point, Dr. Brent. If you make study, we use very accurate sensors, special sensors, such as complete automated weather station, and this have many sensors such as the soil temperature under different depths and the relative humidity in different heights and many things. But for commercial issue, just a thermohydrograph give you the relative humidity and the temperature inside the greenhouse. The technical point in this time where I can install the sensor inside the greenhouse. I recommend that install the sensor in the middle of the greenhouse and in the height 1 meter from the land, because it don't like to make it contact the soil and give good reading for the environmental inside the greenhouse, because environment inside the greenhouse is not the same if the greenhouse not environmental control.
Thank you. That's actually where
one moment. If Dr. Ala Salah, our member is within the attendees, he could give us the name of the list of the sensor we are using in our greenhouse. I'm not sure because I cannot access all names. If Ala Salah, I invited him, but maybe he's
not here, Dr. Abdulazim.
Okay, no problem. Then we'll post later on the website of the project.
I had another question of my own, and it was one or two of the slides showed some greenhouses that were combining both agriculture and fish production, and we've covered so much in a short period of time, but I wonder if you could take a couple more minutes and tell us a little more about your work with those combined aquaculture, fish production, and food production systems.
Muhammad, you have answer?
Yes, sure.
Yes.
But I think you can give me the area of the desaline the water, and then I will continue the smart system we have. If you like, Dr. Abazim.
No, I just answer the question of the attendee. Because okay. In our system, we just installed the tanks for the fish farming, but it is not finalized yet. But attendees saw in your presentation some aquaponic and fish farm in addition to the normal greenhouse.
It's okay. I will do.
Yes, please.
First of all, we try to make the relation between the fish and the plant. Plant considered a biological filter for the fish, because fish produce ammonium. When he eat his food, he produce ammonium, and when ammonium started to concentrate more and more, it's become harmful for the fish. And then we started to make mechanical filter in the beginning to avoid the mechanical residues of the fish. And then we incubate the water of the fish water with Trichomonas. It is bacteria convert the ammonium form of nitrogen, which produced by the fish, to nitrate form. Nitrate form is more friendly to the fish, not make harmful for the fish, and also more favorable for the plants. and then we inject the water with the nitrate to the plants, circulate it to the plant, and the plant starts to absorb this ammonium and this nutrient from the water and make the water clean again, and then pump the water again to the fish pond after the plant absorbs the nitrogen and the nutrient from the water, and it's become favorable for the fish. It's good water, and then the circulation starts again and again and again. Is it clear, Dr. Brent?
That's a good introduction. And it's a very important topic, of course. And here at UC Santa Cruz, we have a very new greenhouse that's trying to do the same thing to integrate aquaculture with irrigation. So
I would like to tell you something. We export this technology now to many countries. I will not mention these countries, but not all these countries is Arabian countries. It is foreign countries in Asia, in Africa, and another continent. We are Egyptian become advanced in this technology, and he knows the tricks in this system, because this work have many tricks. And we solve these tricks with many solutions, and we started to export this system inside Egypt for different investors, and outside Egypt for many countries.
Fantastic. This is the value. In case any of our funders are here in the meeting, this is the value of applied research.
Yes, of
from
course.
the laboratory to the market to helping people throughout the world.
We make friendship with the private sector, and this friendship we make the studies there, and we try to develop the system together, and then it's win-win relation.
Excellent. Well, we have a few minutes left. Any other questions from our attendees? And so Dr. Ala Sami Hafiz Megadhed is asking, can we install this technology in desert areas where we use the groundwater for irrigation and suffer from extreme climate events?
Which technology he's talking about?
I'm not sure. Maybe
Greenhouse.
Dr.
Greenhouse technology.
Is it the greenhouse?
Because the greenhouse is a technology also. Because
Yes.
the way means of saving water, increasing productivity, mitigating climate change. So some people call it technology.
Can I answer, Dr. Abdulazim?
Yes, please.
We have a recommendation for people. The recommendation says that don't install greenhouse in clay soil. Greenhouse in clay soil give less than 50% of the productivity compared to the sand soil. Then sandy soil is perfect for the greenhouse. Why I give this recommendation? Because clay soil holding many waters, and then when you give more water and more fertilizer, it has become not good, because the oxygen started to become low and low in the root zone areas. But in comparison with sandy soil, you irrigate every day, put fertilizer every day, and even sandy soil don't holding the water for many time, and then relative humidity inside the greenhouse, you can control it easily in the desert and in the sandy soil more than the clay soil. Then we give this advice for people: please don't install greenhouse in the clay soil. Install greenhouse in desert. It is very suitable for desert.
Thank you. So Majid El Said had his hand up, and I'm sorry, I didn't notice it until just now. And please, if you'd like to provide some input, the floor is yours.
Hello, thank you very much for this incredible information and webinar. I'm living in Nueva, and my question about the best color for the greenhouse. I use the white one and the black one, but now I'm reading and learning that there is other colors. So I need your advice for what is the best color regarding Nueva. We are planting vegetables and palm dates as well. Thank you.
I would like to answer you, Dr. Magid. It is depend on what you need in the greenhouse. If you would like make shading, then the gray or blue or black. If you need to make shading system. If you don't like to make shading system, you would like to make the plant take benefit from the all solar radiation, please go to the yellow or white color. If you're talking about the cultivate mango under the greenhouse, when we check that, we found that the white color is the best. Because also I recommend the white color or yellow for course, because of we have dust in Egypt. If you start with dark color like black color, and then the dust start to cover your net house, it will be very dark inside the greenhouse. And the plant needs the solar radiation to build himself. He needs the solar radiation for photosynthesis. And then dark color will reduce the photosynthesis inside the greenhouse, especially under dust conditions.
You mean white color, white or transparent?
White, it's a come for you white, no transparent, no net transparent net.
So Dr. Naima Ismail asks, can I use the thermohygrograph outside of the greenhouse?
It's depend what you need. You need to record the temperature and the relative humidity inside or outside. If you need inside, install it inside, outside, install it outside.
Let's finish on this last point made by Dr. Mahmoud Sultan, and he writes, this technology has many challenges for the stakeholders and needs multiple presentations. And that's our way, I think all of us, our way of saying thank you for introducing such an important topic today to both of our speakers. And you leave us wanting more, which is always a good way to finish. And so with that, let's all thank our two speakers, Dr. Mohammed and Dr. Abdelazim, and we'll continue this discussion in emails, and perhaps we'll hold another one of these webinars and pick up where we left off.
I would like to thank all the attendees actually for spending all this time, about 2 hours, staying, listening, discussing. Thanks for all you so much for your time, and you fruitful for discussion. We all of us get benefit from each other. Thank you, Brent. Thank you, Delia. Thank you for Center of Excellence for giving us this opportunity to share our information, knowledge, and expertise in these topics. Thanks, Dr. Muhammad, for this.
I'm proud to be with you, Dr. Abdelazim.
Thank you so much. I am happy that you accepted our invitation and you deliver this very important presentation for us and for the attendees.
Thank you, Dr. Brent. Nice to meet you.
Nice to meet you, and thank you for just a very interesting presentation. All right, and with that, we will conclude. Bye, everyone.
Bye. Bye.
See you.
Thank you.